Okay, so we just sorted out those bounding boxes, and now I will crop those areas of the bounding boxes and pass it to the OCR. The OCR will recognize the text and give it back to me, and then I will write it into some XML file. So this is the OCR part is starting now. The first thing that I need, since I'm using Tesseract OCR available with the OpenCV, I need the trained file. So you can download the trained file. You can write download Tesseract language files and then go to this link. And since I will be working with the English language, so I'm just going to download this eng.trained data. And I put this one into a folder here. It's named as trained data.eng. And we need to copy this path. So remember that we just need this path. And then I'm going to create a string data path is equal to, since I have the escape sequences, and don't forget this backslash at the end. And now I can create an object of Tesseract, and we can give it a name. OCR is equal to new Tesseract OCR data path. And I'm also going to tell this which language. This is the English. Okay, so ENG. And there are different OCR modes available. We can select, for example, there is LSTM only and Tesseract LSTM combined, Tesseract only, whichever gives you the better results you will find out. So basically it's a combination of Tesseract as well as the LSTM. This is the LSTM trend using LSTM only, or the default one. So I'm just going to test with the Tesseract only and see if it gives us satisfactory results or not. And also we need to mention there is dot page segmentation mode, that this one is telling us what kind of input that we are expecting. So I'm just going to select that we are selecting a single block of text. So just try to translate that single block. So since each cell, I am assuming that there is a single block of text. Okay, so that is enough for the setting of the OCR, Tesseract OCR. Now what I want to do is to, once I read all these data, or Tesseract will give me the text file, so I will pass these bounding boxes, the images of these bounding boxes, and Tesseract will give me the text file, and I want to write the text file into some XML, for example. So the easiest and simplest way to work with XMLs is a file or a library which we call it closed XML. So I'm just going to, things are much easier to work with closed XML. So I'm going to add that library using NuGet package manager. And we can write closed XML. And then just select the first one and we can install. You can accept it. I need to go to the home and include that XML using closed xml.xl. Okay, and then I go to 1592. I was here. Now I want to write into Excel variable workbook is equal to new Excel workbook. Okay, and also I need a worksheet. Worksheet is equal to workbook dot worksheets dot add. Let me add a new worksheet and just I call it outputs. So it will add a new worksheet into my workbook. And now the workbook is also ready. What I need to do is read all those text one by one. So let me say row counter. I need some variables to define here, and I need another character. Column counter is equal to A. This is just, since the Excel has columns and rows. One is in A, B, C, D column name, and the row number is in 1, 2, 3, 4. So I need to mention where, in which cell of the Excel I want to write. So now let's loop through all those elements in my bounding box. So integer I and sorted boxes dot count. So variable rectangle, I'm going to read each one by one. Sorted boxes of I. Okay. During testing, I find that there were some extra space were coming around the boundary. So I want to get rid of that boundary area. So what I'm going to do is with the X, I'm going to add the offset that I am sending, and also for the rectangle dot Y. This is just to overcome the issues along the boundary. Okay, and also I will do the rectangle dot width minus, because I just need to reduce that one, minus equals to offset. If it is not required in your case, you can ignore that one also. Minus equals offset. So just I made the bounding rectangle a little bit smaller so that I don't have any issues along the boundary. Now I need to read from the IMG table. So if I need to read every cell of the image, so I need to set its ROI to be the current rectangle. Now the OCR's input will be a set image. This is the image that we want to input. Set image. So this is the IMG table dot copy. So I'm going to send basically a copy of the image here so that my original should not change. So that is the input for my OCR, and we hope that this OCR will give us a text back. So OCR dot, so I'm using this get UTF-8 text, and since it will also give us some backslash and that, so I'm just going to replace those with backslash r backslash n, and I don't want to keep the information about the backslash r backslash n. So it will give me just plain text whatever, because it is adding this return also at the end of the text. So this is, it's done. It's done that we read the text from the image, and now I want to write it into Excel. So I just need to go and check if I percentage number of columns, so how many columns we have, if this one is equals 0, and if I is greater than 0, then I need to do the raw counter plus plus. So it means that I'm just going along the first row, and then what I need to do is column counter is equal to, it will be the A, because we are in the first column, and then we will write into the worksheet dot cell. So in which cell I'm going to write is column counter dot toString, and plus whatever the raw counter we have, raw counter dot toString. Okay, and then dot value of this cell will be equal to the text, whatever the text we have. So this is indicating that this is the first column. So whenever the column is first, we cannot increase it, so we need to set the column to be A. So we will read the next cell, the next cell in the same row. If it is not, then we need to change the row number. So this is what it is doing. Column counter will be increased, and we are doing the same thing. Worksheet dot cell, here we are saying column counter plus raw counter dot toString. It will be like A1, A2, A3, A4 dot value is equal to text in the next row. And once we finish working with the current ROI, what can we do? Img table dot ROI is equal to rectangle dot empty, so that we will start working with the next cell, and then we will again set that cell here, and we just work with that. Once we finish working with that cell, we will set it to empty. So we assume that at the end of this loop, it goes through all the bounding boxes, read those bounding boxes, pass it to the OCR, and it will give us the text, and this is just for writing into the Excel file. You can write it into a text file, it doesn't matter. So this is for the first column, and this is for the rest of the column. So we are writing it row by row. Okay, at the end of this, we assume that the worksheet, it has been written in memory of the worksheet, and now we can actually write this workbook into some, for example, I'm just going to write somewhere here. I'm just going to write here output. And this is the path where I want to save. So I'm just going to write here at the rate, sorry, should have been a double quote, slash, and I'm going to write it output dot xlsx. So I assume that after reading in the loop and after recognition, it will write into this location, and we don't need to show anything actually here. Maybe we can show a message to the end user that message has been a message box, or maybe one thing I will do, it is string output path is equal to this, and we are writing into output path, and we can say data is saved successfully in following location \n, so that, and then I can show the path. Output path, I should write output path. And one more important thing that I missed somewhere here is to mention, once we get the contours, and I just directly converted the contours into bounding box and I process it, but there might be situations where we might have a contour which may not be a cell. So we need to filter out those contours as well. So we will define a minimum area of the contours so that we will accept those as the cells of a table. So this is very important, otherwise there might be a problem. So I will basically define a method which will filter out the contours based on area. So if the area is less than that amount of pixels, then we will remove those contours as well. So to do that, let me write that method right here and call it private vector of point. So it will return us the contours. So I'm calling filter contours, and this is expecting a vector of points. We call them contours, and a double threshold value. Let's say I want to set it to 50. So the area should be greater than or equal to 50 at least. Then we can provide the value here. And I need to define a vector of points. I call them filtered contours is equal to new vector of points. And now I'm going to loop through all those contours that have been sent. So contours dot size, and if CV invoke dot contour area. I'm going to find out the area of the contour, and I'm going to select the contours so I calculated the area of the contour, and if this is greater than or equal to this threshold, then we are going to accept it as a contour. So we are going to add it into the filters contour. Filter contours push, and the value right now is the current contour, contours of I. So its area is greater than this threshold, so we want to push it, and now we assume that the filter contours will have all the contours whose area is greater than this one. So we need to call this method somewhere before converting it into getting the bounding box list. So let me go there, and I will call this method, I call it filter contours is equal to filter contours method, and here we are sending the contours, and this should be before this one, sorry. Here we need to send all the contours, and let's say I want the minimum area to be at least 500. So once we filter the contours, then we can basically convert them into bounding boxes and then process it onwards. So now it's, I think, ready, and we can run it and see the results. File, open. So let me open the same table again, open it, and now I try apply. The data is saved successfully to the following location, and let's go and see on that location what we have received. This is the input image of the table. This is the output that we have received. Let me compare it. Okay, so this is what height, centimeter, weight, 6, and all these things are okay except this F. So to do this, to play with these parameters, we might need to change these. I'm going to add a new Windows form, and let me call it form parameters table to text. And I already created these, so I'm just going to paste them. These are just some of the controls you can use simply, labels and text boxes. And once we double click on this apply, so we can create a public event, public delegate, and call it is returning void, and delegate table to text. And this one is, we need how many parameters? Just a minute. So this one will take the same number of parameters as we have. So I'm just going to quickly create a parameter with the same number of parameters. So I'm just going to remove these default values. Okay, and okay, so this is the delegate that is expecting a method with the same number of parameters that we have. Let me bring this one here. Okay, and based on this delegate, we will create another event, and this is basically based on this delegate and on apply table to text. And I will also customize this parameter so that we are getting some I'm just going to change the default constructor, and using these values I'm going to show in my text boxes. So text box number of columns dot text is equal to number of columns that we have, and text box morphological dot text is equal to morphological threshold dot text, dot toString, and here, instead of writing it here, I will do it here, dot toString, and also text box binary dot text is equal to binary threshold dot toString, and also text box offset dot text is equal to offset dot toString. So these are the default values that we will show just in the constructor. Now in the button.click event, once the user clicks it, we want to update the main form with the new parameter values. So here we can use a try catch, and if we have an exception, we can show it message box rex.message. And here what we want to do is, if on apply question mark, if this is not null, then we can call it invoke method dot invoke, and this one is expecting the same number of parameters that we have. Now the user might have changed from our text boxes, so I'm going to write them here, text box number of columns dot text, and since this is a text, so we need to parse it into an integer, so I'm just going to pass the first one is like this, and the second parameter float dot parse text box morphological dot text. The third parameter is also integer, so integer dot parse binary text box binary dot text, and the last parameter, I need to write a comma, and the last parameter is also integer dot parse, and this time we are reading from text box offset dot text. Okay, so we can change those parameter values from here, and then once we click it, it will update our main form event. So I need to go to the settings, and here I can write try catch also ex, and then we can show a message box here, ex dot message. So right here, when we are going for the settings, we just need to create the object of form parameter to table list. Form is equal to new form, and this one is expecting the default values, and I think it's best way to pass whatever the default values we have. What were the default values? I don't remember. We can 430 205 430 205. Okay, and once we pass these values, now we can also set which method we will call if we want to call back. So this is the method that we are interested here. Actions is the apply table to text method. So this is important. So we just inform this on apply what it is saying, plus equal to, we should not forget it. So in this event, once we click it, we are interested to call this method. Okay, and then we can form.show dialog. So let's run again and see. File and open this table that we are interested. Okay, and then instead of applying, I'm going to the settings. So we want to apply these parameters. Let's say we have 4 columns here, so it's okay, it's 4 column. And if I apply, let's see what it says. To this location, okay, it has been written. I didn't make any changes, just I want to see if anything happened or not. The F is being missed out here, threshold value to 150. So now you can see by changing those parameter values, we can control how we can extract the amount of information, and I think it looks perfect in this case. Is there any problem? These are male, male, female, female, sex, weight, height, centimeter, age 10, 15, 20, 10, 15, 20, 160. So it looks perfect. Now let's say we are, let me try with another one. I'm going to close this. And now I am interested in another table with just two columns. And in this case, this parameter is very important, and we are going to change, instead of 4, we have 2 columns. The rest I'm just keeping them as it is to see how it works. Okay, you have said location, saved it in the location. Let's see what you have for us. So if you house price 255, okay, but there is some problem. Square FWT, what is this? There is some misunderstanding, but it's okay. I just need to check if it is possible to deal with this issue by changing these parameters or not. So if I reduce it to 150, for example, apply, okay, and now let's try this again. So that is even perfect. Given an image of any table, we extracted the information present inside it. I hope that this video was useful to dig out more about EmguCV CV and how can use it in your project. And I hope to see you in another video.